I decided to up my presentation skills a little bit. It's just HTML generated from Markdown. Anyway, I just thought it would be a bit easier. I was going to talk about Jim has a pull request to improve MP remote with recursive directory sync, proper recursive directory sync and hashing. But it's not ready, and I didn't really have enough prepared to talk about it. But maybe that can be done next time. So instead, I'll just go through a bit of the things that have happened since last meetup. So the LoRa, I have discussed and even given a demo before. Angus Grattan has worked really hard to get a pure MicroPython LoRa driver finished, and that's now merged to MicroPython lib. And when you use this, you've got to choose. I think since the last time I demoed it, the API changed a little bit. And what you need to do is you choose your driver, like your hardware driver. So your Semtech SX1260, whatever, or 1270. And then you also need to choose if you want a synchronous or an asynchronous API. They can both be useful. Underneath the hood, they're actually implemented with interrupts, as if you've got an interrupt pin on the Semtech. Asynchronous is obviously good if you want to plug it into an async IO app. So you can MIP install one of these you MIP install a sync or an async package, and then also the driver that you need. And then you can select, there's sort of a multitude of then things you can select from. So if you want a synchronous, you just give the name of your hardware. So for example, SX1262. Or if you want asynchronous, you prepend async to the driver. And so here, if you've got a 1276 and you want the async driver, you can import that from the LoRa module. And then you can use read and write and you've got to configure it and so on. But I won't go through that because I have demoed that before, and there's really great documentation by Angus on the in the README for this driver here. So it explains what chipsets are supported, the installation, like I just briefly went over, and then how to instantiate the driver, and how to pass pins to it, SPI bar, so it needs a SPI and a chip select at least, and a basic configuration for like what frequency it should run at, and that will already get you started. And then there are other further configurations you can do. And so it tells you about the parameters, and how to configure the modem, and there should be an async section towards the end. So you can see it's actually quite long and comprehensive there. So if you need to, if you're going to use it, I suggest reading that. There are a few examples which are useful. Can start with the simple send and receive example. There's a synchronous and an asynchronous version. So once you've created the modem, which is what this code is doing, then you can just create a sending and or receiving task, and it's really quite as simple as just await modem.send and send the data, or await modem.receive. So it's very cool. Works really well. So if you have any,
really well designed. I'm really impressed with the way this has come together. I mean, it's been a long time in the making, but it's fantastic.
Yeah, and the fact that it's pure Python is, I think, a great bonus, because it means it works anywhere that you have you don't need async IO. All you need is a pin and an SPI or a SPI-like object, and it will be able to connect to the Semtech. Still to come is support for STM32WL5X, which is internal Semtech sort of on the chip. But this works with any external Semtech device. So if you want to play with LoRa, definitely try this out. It should work on any board. It's been tested on RP2040s and STM32. Not sure I tested it on ESP32 though, but I don't see why it shouldn't. It should just work on anything. So yeah, that's all merged, so easy to MIP install. The other thing that was merged that's already again been demoed, I think last time by Jim, was the new deflate module, and back then it was called gzip, but he did mention it was going to be renamed. So we came to the conclusion that for all the usual reasons with MicroPython, that you want things to be minimal and use less memory and be, good to run on an embedded context, that the existing Python APIs for compression and decompression didn't really provide what we needed there. So what's been implemented is a custom MicroPython deflate module, which doesn't exist in CPython, but you could implement one for CPython. And then that provides a deflate IO, which is a stream-like object that can do both compression and decompression. Decompression is an optional feature, but yeah, if you read and write, it will do one or the other. And then that can support raw, deflate, gzip, zlib, and gzip formatted files, which are just have basically headers around raw stream. And then in MicroPython lib, there are pure Python packages, zlib and gzip, which are CPython compatible, which provide the CPython API to do compression and decompression for those in those packages. And they are built upon deflate IO. So deflate IO was designed so that it's very easy to implement zlib and gzip on top of it. But if you want to do streaming compression and decompression, which you probably do if you've got a lot to compress or decompress and it can't fit all in memory, you're recommended to use the deflate IO interface. You can also use gzip.gzip file, which is also stream-like, but deflate IO gives you more control over the window size, how much memory it uses, and the format, and it's a bit more flexible. And that's documented in the docs. So yeah, it should be available to use now. So that's been a long time coming. Compression, I don't think it's enabled on all ports. If you want that, you might have to build yourself and increase the feature level to the extras. Or no, full. I think full is where it's enabled. But yeah, because it's quite large to add this. It's also available as a dynamic module if you wanted to install it that way. The other thing so a lot of things with MicroPython lib, the other thing that was updated in MicroPython lib was hashlib.
Yeah, you mentioned, is that like a dynamic native module?
Sorry, yes, it is. It's this, yes. You can compile deflate as a dynamic native module. Yes. But you have to, yeah, that's not available like to download. You have to actually build it yourself.
Yeah, sure.
So hashlib, so the board has usually built-in hashlib, but there is one on MicroPython lib that provides more algorithms. It's now been split up, thanks to Jim again, into a component-oriented version. So you can either MIP install hashlib, which gets you everything, or you can just MIP install the ones that you need, because they're quite large and they're really not memory efficient. It's just there if you're really desperate for this hashing algorithm. It will use a built-in, if the implementation is there in C, it will use that. So I think one of the SHAs, I think 512 is in C. So we use that if that's available. If it's not available, it has a fallback to a Python implementation, a pure Python implementation. So yeah, this has been reworked. The other things to follow up with the module renaming. So the idea was to move away from new module naming, which we've done in the main repository. So now you can just import time, import async IO, and it matches CPython, which I think is great. And actually, probably to mention that's why we're doing things like deflate module, which is completely separate from CPython. So it's not called uzlib, it's called deflate, which is just distinct from CPython. And we can implement that for CPython if we want. So if a module is going to be called CPython, well, try to be compatible with CPython, it should be called by the same name, i.e. zlib, and provide the same API. And if we're going to do something different, it'll just be a completely different name. This is a bit more in line with how CircuitPython is doing the things they do and their philosophy to be strictly CPython compatible, or at least a subset. So the module renaming that we've done, we're just following up in MicroPython lib. So utar file has been renamed to tar file. That does not have any backwards compatibility. Sorry, there's no backwards compatibility shim there, so you'll have to update any code that uses that. And it also has write support now, optional write support. And uRequest has been renamed to requests. Because that's such a popular package, we have added a backwards compatibility layer there, so you can still install uRequests, and it will just forward to requests. So that's a nice cleanup. For firmware, MicroPython firmware, ESP32, again, it's a very popular port. There's lots of activity on that port, and we moved to IDF5 recently. A few bugs there were fixed, including machine spy constructor and timer, and also a new Arduino ESP32 based board, the Arduino Nano ESP32 board. And for this, we've added named pins to ESP32 finally to match all the other ports. I think most of them now have named pins. So that's when you can construct a pin not from an integer but from its name, which is only enabled if the board has actually defined a name for those pins. So that's there. And then finally, down the bottom here, a nice feature with MPY Cross is it now supports piping from standard in and standard out. So you can don't need to use files or temporary files anymore. You can just cat a Python file into MPY Cross, and then it will output the compiled bytecode to standard out, and you can do whatever you like with this. Of course, you don't have to. You can use the standard way of loading and saving files, but pipes are sometimes useful. And also, so the next release, 1.21.0, was scheduled for a month ago. That was a very, very optimistic timeline. The only thing really stopping that release is the need to fix the heap size configuration on ESP32, because with the move to IDF5, things had to change a bit, and at the moment, if you have SpyRAM, you can only use half of your SpyRAM the way it's configured. So Angus and I had a bit of a discussion today about how to fix this, and we should be able to move forward with that in the next week. So yeah, that's my sort of mini roundup of MicroPython development changes in the past month. Yep, that's all I had to say. Happy to answer any questions.
Other couple things in chat. Let's have a look.
Sorry?
No, looks okay.
Okay. I see that's right.
Yeah. Just checking the chat. I think it's clear. Did anyone have any questions, or what the hell is Damien talking about, or anything like that? No. I saw you allude to the named pins, but I think that whole feature is actually new, Damien. So I had to wander off for a bit there, but
it is that. Yeah. On ESP32, named pins is a new feature. Yes.
Yeah, so that's pretty cool.
Yep. Although, as I said, it's only on boards that actually name pins, which is only at the moment this new Arduino board. Yep. So we might have to go through and see if any pins need naming on other boards.
Yeah. So cool. That's great. Excited about that one. How's I remember there was the memory issue in ESP32 holding out. Well, I guess it was the general question is, how's 1.21 going? And I know one of the big blockers there at the moment was the memory use since moving to IDF5.
Yes. Yes, I did mention that as my last point down here.
Oh, sorry. Yeah.
Yep.
Cool.
So that is the main thing blocking the next release, is to fix the heap size.
Ooh. Okay, well, shut up. Yeah, ducky out for like just a minute to pick up the pizza.
Yeah,
so
I was gonna say, the pizza just arrived. You know, there's
Yeah. Right. Okay.
All good.
Cool.
All good.